Hello, class. I want to keep talking about infinite series. In the last section, we talked about specifically series that contain only positive terms, and the test that we applied, I guess the main test was the integral test, and that really only applies to series with positive terms. So just make sure you understand that, and if you, it has to do with the geometry of what we talked about. But today we'll talk about alternating series, and we'll still use the integral test, but there's some specific kinds of convergence involved. So this one is about alternating series, and what I mean by that is that series that change from positive to negative, positive to negative, positive to negative. So just as an example, we'll consider S sub n equals 1 plus 1/4 minus 1/16 plus 1/25 minus 1, minus dot dot dot. All right, so this is a series of squares, and I guess it'd be good to write this out so you see the notation. S sub n equals the sum from n equals 1 to big N of, we still have, it's obviously there's the 1 over n squared term, and I'm going to put that a little further out here, so 1 over n squared, because that's what's in the denominator. But what I'll put in front is something that has an index -1 to some power. So -1, I guess it's going to be to the I better change that. I better change this first term to -1, just to make this work. -1 to the n power. So when n is equal to 2, then that -1 becomes a positive because it's -1 squared. There we go. -1 to the n. All right. So this will alternate the sign. The sign, S-I-G-N, sign. Okay, so that'll change it from negative, positive, negative, positive, negative, positive. All right, so when you have an alternating series, you can visualize it like this, and I'll first do the 1 over n squared, and we'll just sort of plot out the terms. And I think once you see it, it'll make perfect sense. Machine is hung up here, so there we go. It'll make perfect sense. A, why we can talk about convergence the way we do, and B, what an alternating series kind of looks like. So if we plot it, I'll plot sort of, I'll make this n equals 1, 2, 3, 4. In an alternating series, etc. So this is sort of like an n-axis. An alternating series, this one, for example, if I make this down here -1, so that makes this +1. So here, what my terms look like, I have this, and then 1/4. And now they're just getting closer and closer to the axis. And if I keep this up, eventually it'll be so close that we can't even tell. So, but it goes up above the axis, below the axis, above the axis, below the axis. What we're going to do with alternating series is look at the convergence of the absolute value. So, the absolute value of this alternating series. So I'm going to say the absolute value, if a sub n is -1 to the n times 1 over n squared, we will look at, so we're going to look at the absolute value of a sub n. All right, which is really just going to get rid of the -1. So since that -1 is going to be irrelevant, then this is just this. So we're going to look at the absolute value, and note that for any absolute value of the sequence, all terms are positive. Okay, which means integral test applies. So if we do sort of the positive version, I'll put that in blue. I'll do it on the next page. So if we do the positive version of that series, or of that sequence, it looks like this. So the red is a sub n. Thing is hung up again. The red is my a sub n, and the blue is the absolute value of a sub n. So the blue will be there. Oops. There. And it will overlap, so I'll put it just right beside it, and then there, and there, etc. So when we have the blue one, we can apply the integral test. We can draw the rectangles and that kind of thing. So, and I think it should be clear that, if we're adding terms together, let's say if we look at the red again, the -1 plus 1/4 minus 1 over 16, 1 over 9, minus 1 over 9, etc. Dot, dot, dot. If we compare that to the blue, which is 1 plus 1/4 plus 1/9 plus 1 over 25, etc., that the blue one can only be larger than the red one. So the blue can only be larger. So this is like a comparison test. So the absolute value of a sub n must be equal to or larger than a sub n, and therefore if this converges, so the sum from n equals 1 to infinity of a sub n, if that converges, so if that converges, then the one without converges. And in fact, for any series, All right, and I think that's pretty straightforward. And by now, I think you should know that actually the squared one does converge. The blue here. So you know, we can do an integral test. We could do the integral from 1 to infinity of 1 over x squared dx, and this is a p-series kind of thing. So that's going to be what, negative 1 over x evaluated from 1 to or I'll just write 1 to infinity, but you know, really there's a limit as b goes to infinity, and this converges at well, it has a finite value, right? It's 1. Is that the finite value? Yes. So you know, that means that the 1 over n squared series converges, which means that the negative 1 to the n times 1 over n squared converges. And in fact, what we say is that it converges absolutely. There are two types of convergence. There's absolute convergence and conditional convergence. Okay, so for absolute convergence, okay, that's if of an absolute value if the absolute value of a series converges, then the series converges. Absolutely. So if the absolute value of a sequence, if an absolute value series converges, then we say that, boom, the series without the absolute value terms converges absolutely. And the other one, and I'll talk more about it in the next segment, is conditional convergence. Let me underline absolutely. Okay, so conditional convergence. And we're going to have to come up with a couple more tests for conditional convergence, but we'll do that. It won't be so hard. So if the absolute value one diverges, but the regular one converges, then we say that it converges conditionally. And again, my thing is stuck here, so I'm going to wait a minute. So if the absolute value one diverges, and I'll do an example of this in the next segment, but this one, n equals 1, to infinity without the absolute value, if that converges, then we say that the sum from n equals 1 to infinity, a sub n, converges conditionally. So there are two types of convergence. There's absolute convergence and conditional convergence. Absolute convergence is when a series converges and its absolute value terms also converge. Conditional convergence is when the series converges, and that would be an alternating series, but its positive counterpart diverges, then the series only converges conditionally. Okay, so that's going to be it for now. Good night and good luck.